Casey, in this particular example, we started with copper and the nitrate going to copper ion and nitrous oxide. Help me just by writing the first of the two half reactions you wrote down. Perfect, thank you. And then, John, what would the second half reaction then look like? Thank you. What I do, and it's just a little bookkeeping, I try to keep the arrows aligned up so that when I go to add them back together, I can clearly see what's on the left and what's on the right. Rule number 1, we broke them into two half reactions. Rule 2 says we want to balance everything that's not an oxygen or a hydrogen, and those look to be done. Rule 3 says let's balance the O's with some water. I don't see any O's in the first half, but I do down here. Troy, help me balance the oxygens in the second half reaction. Perfect. Good work. Now there's 3 on both sides. Emily, what we'll then do is balance the H's. First one has no hydrogens to balance, but you could help me down here. What should I do to balance hydrogens? Perfect. Good start. Now we're ready to check some charges. Aaron, in the first half reaction, the more positive side needs to have electrons added. How many did you place in the first half reaction? Excellent. Marissa, to the more positive side on the second half reaction, which by the way is now at a net positive 3, we decided, over here is 0. How many electrons to the left side did we add? Perfect. Courtney, just a little Leo Gurr practice. In the first half reaction, we're seeing electrons lost. Does that look like oxidation or reduction? Exactly right, and you said it right both ways. Leo is the loss of electrons, oxidation. And Alex, how about helping me label the second one? Exactly, sounds funny. Gurr is right, it's a reduction half reaction. BJ, if 2 electrons were lost in the first, but 3 were gained in the second, we have to make sure Leo equals Gurr. What did you distribute through the first half reaction and the second half reaction to get them both to be the same number?
I times the first one by 3 and the second one by 2.
Excellent. Turn them both into 6s, and now we can distribute as we add back together. So I'm just going to bring my arrow down, adding everything down together, distributing at the same time. Nate, get us started with the first half reaction. What would I place on the left side when I combine them back together?
3 copper.
Excellent. And Taylor, what would go down and I add the left side for the second half reaction? 6 Perfect. All right, now I'll just add on that -1. So everything comes down and you distribute it at the same time. Perfect. Clear, back to the top half reaction, distributing and placing over here. What goes on the right side? Excellent. And Nicole, distributing, what would I place for the second half reaction? Excellent. And Nate, what will simplify? Otherwise we'd cry as we had to start over. Anything else? I don't see anything else. Looks like our final answer is produced just by eliminating the electrons, and we have a balanced redox reaction for the acidic solution. Alrighty. Let's take a little look here. I'm going to ask you to just think about this. Divide this into half reactions, or can we? Let me pause and ask you to just think about this with a neighbor. Is it possible? Notice the little title here, a little different. What might the half reaction look like here?